When we talk about artificial intelligence and software development, the first image that comes to mind is usually a code generator. We imagine a tool that writes the boilerplate for us, fills in the blanks, and spits out functional snippets. It is a powerful capability, but it is also a dangerous one if left unchecked. Relying solely on generation without verification is like hiring a junior developer to build a skyscraper without a senior architect reviewing the blueprints. The code might run, but it might not scale, it might not be secure, and it might break under conditions you never anticipated. This is where the workflow needs to shift. We need to stop treating artificial intelligence as a passive typist and start configuring it as a strict, senior-level code reviewer. This is not about asking the machine to write the code for you. This is about asking the machine to critique the code before a human ever sees it. The goal is to catch scalability issues, security vulnerabilities, and edge cases in the early stages of development. By doing this, we leverage the speed of automation while protecting the integrity of the final product. To understand why this matters, we have to look at the current state of the technology. Recent research highlights a dual trajectory in the field. On one side, we have rapid technical expansion. We are seeing agentic artificial intelligence and scalable systems revolutionizing what researchers call the easy problem of science. This involves optimizing defined functions for tasks like protein folding or financial analysis. In the context of coding, this translates to pattern recognition and syntax generation. Artificial intelligence is exceptionally good at this. It can recognize common patterns and apply standard solutions instantly. However, there is a critical disagreement emerging regarding the hard problem of science. While technical papers focus on engineering solutions, scholars argue that current artificial intelligence lacks the capacity for conceptual revision and problem formulation. This is a capability inherent to human cognition. We know that true scientific breakthroughs require agents that can infer and update paradigms, not just optimize metrics. When it comes to code, this means artificial intelligence is great at writing a function that works, but it is less capable of understanding the broader architectural implications or the long-term maintenance burden of that function. This gap suggests that the most effective workflow is a hybrid one. We use the machine where it excels at optimization, which is the easy problem, and we keep the human in the loop for the hard problem, which is problem definition and conceptual oversight. When we configure artificial intelligence as a reviewer, we are asking it to apply its optimization skills to the quality of the code rather than just the creation of it. Here is the thing about this workflow. You start with a human writing, the initial logic. This ensures the intent is clear. Then, you pass that code through a specialized artificial intelligence layer designed specifically for critique. This layer does not generate new features. Instead, it scans for potential failures. It asks questions like, what happens if the input data is malformed? Does this function handle concurrent requests efficiently? Are there any security vulnerabilities in the way data is being passed between services? This approach aligns with the emerging trend of agentic artificial intelligence. We are moving from singularity narratives to a plural, social intelligence model. The challenge lies in designing systems that match human creativity in problem definition, rather than merely surpassing human speed in execution. By making the artificial intelligence a reviewer, we are essentially giving it a specific role within a team structure. It is the senior engineer who reads the draft before it goes to the client. Consider the implications for security. In a traditional workflow, a developer might write a function that looks correct but inadvertently exposes an endpoint to injection attacks. A generative model might not catch this because it is focused on syntax and logic flow. A reviewer model, however, can be tuned to specifically look for security patterns. It can flag code that violates best practices for authentication or data encryption. This is a practical application of the dual trajectory mentioned earlier. We are using the machine to handle the repetitive, rule-based checks, which frees the human to focus on the unique, complex challenges that require conceptual revision. Furthermore, this workflow addresses the ethical concerns regarding alignment and fairness. As the field shifts, the challenge lies in designing systems that match human creativity and problem definition. If we let the artificial intelligence generate code without review, we risk embedding biases or unsafe patterns into our infrastructure. By requiring a review step, we introduce a layer of accountability. The artificial intelligence acts as a filter, ensuring that the code meets specific standards of scalability and robustness before it reaches the production environment. There is also the matter of edge cases. Humans are notoriously bad at anticipating every possible input scenario. We tend to write code for the happy path, the scenario where everything goes right. Artificial intelligence, when configured as a reviewer, can simulate thousands of variations in a fraction of the time. It can identify where the logic breaks down under stress or when unexpected data arrives. This capability is crucial for building software that is resilient. It bridges the cognitive science of human problem-solving with computational architectures. We currently lack agents capable of autonomously defining scientific questions under poorly defined constraints, but we do have agents capable of rigorously testing defined constraints. As the field shifts from singularity narratives to plural social intelligence, the challenge lies in designing systems that match human creativity in problem definition. Future progress depends on integrating these cognitive insights with the robust, data-driven optimization frameworks currently dominating the landscape. We are not replacing the human, we are augmenting the human. The human remains the architect, the one who defines the problem and the vision. The artificial intelligence becomes the inspector, the one who ensures the vision is built to last. This shift represents a maturity in automation. It moves us beyond the novelty of generation into the utility of verification. It acknowledges that while artificial intelligence is rapidly expanding its technical capabilities, it still requires human guidance for the hard problems of context and meaning. By adopting this reviewer workflow, we create a system where the speed of the machine meets the wisdom of the human. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.